Alright, so here we are in this quick experiment for Tinkercad, just to understand a little bit what is called a pull-up resistor design. This switch is configured as a pull-up resistor. When you press it, it goes to low. When you don't touch it, it's in high state, meaning that the pin connected to it, which is pin number 3 here, is an input. If you press it, that input, meaning that pin 3 will go to low. When you don't press it, pin 3 will stay high due to the pull-up resistor, this resistance here. And this resistance, let's see if we can pull up. Okay, let's see. Oops. There we go. 10 kilo ohms as a pull-up resistor, and this one is 150 just for protection of the LED to avoid going above 20 milliamps. Basically, that's it. Let's see how this behaves. Start simulation. When you press it, turn the LED on. When you press it again, turn it off. Turn it off. If you keep the push button pressed, nothing happened until you release it. I release it. It was off, it turned it on. If I press it again, you see that it stay on until I release the push button finally. I release it, then it switch off. Switch on, switch off, and that's basically it. So let's get busy. Let's build this circuit. Alright, so let's start with Tinkercad. So we go here, Google, Tinker, Tinkercad, right there. So we launch it, and we go to circuits, and how about create a new circuit? And there we are. So what we need an Arduino. Let's put it all together. Right here, Arduino. There are many things here that are already pre-done. I'm gonna pick let's see, it's interesting. Seems like wow, many stuff done. Actually, let me back up from here for a second, and so let me pick an Arduino but without anything on it, because that's basically many stuff done, and I don't want that. So now here we are. So we got the Arduino. How about the breadboard? We're gonna pick small one. Here we go. And what else I need? We're gonna need a LED, at least a LED for this experiment. Let's have the LED somewhere here. That will do. And now the idea is that when I press the switch, the LED will turn on. When I press again the same switch, the LED will turn off. All right. So with that said, the power to the LED will be from pin number 2. So basically we need a resistor. Gonna put that somewhere here. All right, so now I can certainly that will be pin number 2 will be the output. That means I like to go through like this a little bit, some idea, not to make this crazy. There we go. So power will go through here, through the resistor, which should be about 150 ohms. That will do. Now the negative obviously will go, you can certainly do this, look good here, and then from here you go say here. Now I only need to get this ground here, any ground here, and now I need the positive. If I want to use the positive, actually, let's go through here and let's go here and let's go right there. Let's fix this so they look good. Good. Now let's switch some color here. Ground will be black, and this one is power, so red. How about this one? Well, that is input output, so with that one I will go let's see, yep, that will do. Now let's see, this is interesting. All my everything on my anyway on my website here is Spanish somehow. That's weird. It's supposed to be in English, but no big deal. It's the same thing. Anyway, so right there, how about this? Well, these are the negative, so I'm gonna get them in black, make life easier to understand what I'm doing. There we go. So I got pretty much the LED in good shape. You can quickly test it just to be sure that the LED turn on, but it's not a big deal. The important part is how to accommodate what is called the pull-up resistor. That's the important part, the pull-up resistor. For the pull-up resistor, let's work on the switch a little bit. Here's the switch. Now we put the switch anywhere, you know, here. Let's do it here, near. What will that do is, for example, so I have the switch. Now we're gonna do a pull-up resistor. What that a pull-up resistor mean? It means that it has a resistor here connected to the most positive part of the switch, and that switch should be, I mean, that resistor should be about 10K, which is 10 kilo ohm. That's good. So this is connected here. Now this is the interesting part. We're gonna use pin number 3 as an input. So from here, I'm gonna go, and the main idea, actually I get it right here, so it looks looks a lot better. Actually, let's see, I can go through them and connect it somewhere here. I can definitely pull this. Well, it doesn't matter. It will stay there. Okay. Now, when you do that, if this switch, the only thing that you need to do is to take the other leg, this leg and this leg are combined when you press the switch. So the only thing that you need is to put this into ground. There we go. Now let's change the color of this, and so I can definitely accommodate this. Looks better, and that will do. So I think from the point of view of all the connection that I need, we are done. So when you press the switch, the idea is that the LED will turn on, and when you touch the same switch again, the LED will turn off. Now let's check this resistor again, 150 ohm. Let's check this one again, 10 kilo ohms. The switch is right there with one leg to ground, but this leg is raised by this pull-up resistor, which is about 10K. So that's the main idea. Well, I think that we are done with the circuit. We now go to the code, and to the code we go text, and here we are. So this text here remind you what pretty much this C code for Arduino is all about. There's very simple definition, like for example pin mode. This is sort of like a small code there to give you a hint of how to program the Arduino. So I I'm not using the built-in in this point, but I can certainly use the pin mode instruction, because that's the instruction I use to define which pin is going to be input and which pin is going to be output. In this case, pin number 2, based on this, let's see, pin number 2 is going to be an output, because that's actually is going to the positive of the LED, positive leg of the LED. So now I need another of these, but not to define another output, but to define an input. And let me get this straight. So that's going to be pin number 3. That's an input. So we need to change this, and we need to change this as well. Input. Now, so I got these 2 pins defined, 2 and 3. 2 being an output for the LED, and 3 an input from the pull-up resistor. So the next thing is getting into the void loop, and this is open with this bracket. So the next things that I need to do, and this is the part that I'm gonna take all this for 1 second, because we're gonna rewrite the code a little bit here. So for example, if you don't press the push button here, if you don't press it, so the Arduino, when it reads this pin number 3, when it reads pin number 3, will always read that is in the high position. It is only when you press it is that this point here, you know, where I'm showing right now, it goes to the ground only when you push it. So it's changed from high to low. That's the important. When you press it, change to low. The voltage that pin number 3 will receive is a low voltage, means 0. If you keep it the way it is right now, the voltage will be high, will be 5 volts. So a good question will be mientras, right? The word in Spanish is called mientras, while. In English is while, and then while what? Digital, and here's how to read a pin. While digital read which pin? Obviously number 3, which is an in this case is an input, and it says while digital read the of pin number 3 equal high. High is a reserved word. It should be capital letters. While digital read equal. Now this equal is not 1 equal, it's 2, because it's a comparison. If the content of this digital read is high, which means equal to this one, then you know what we're gonna do? Nothing, because you haven't pressed yet the push button. So that means that the only thing that we're gonna do while the digital read 3 equal high is nothing. Stay there. We're gonna do something when we press it. In that case, it is interesting because sometimes you can keep your finger on, pressing the push button for a longer amount of time. So you want to be sure that you capture that as well. So to do that, we're going to add another while. Another while. And we're going to check the same pin. And we're going to say while digital read. Check that instruction. Digital read is a reserved word from Arduino. So you got digital read 3 and equal low. What that will do is the same as the other one, but it will capture that you still have the push button pressed and you haven't released it yet. So the first one, this one, if you hit or push the push button, it will get into the second one, to this one. And this one, it will check that you have released the push button. If you haven't release it. You still keep pressing the push button. It will stay here until you release it. Okay? And so now here we will ask some question, like for example, if let's add a variable here, and I haven't defined this variable, but it's kind of nice. What the push button will do, it depends of the status of the LED, whether the LED is on or is off. So with that said, let's write a variable that has some meaning to us, and we'll say on or LED status. Let's write the word LED status, LED status. To write a variable, I always use kind of an underscore status. Okay, LED status. If that LED status, and this is a question again, this is different than from while. I'm using the instruction if LED status equal 0. I'm defining that variable in a second. If LED status equals 0, since I'm asking a question here, let's open that with brackets. And if it happened that the LED status equals 0 in this comparison, it means that the LED is off. So I want to turn it on. That's the main idea. Turn it on. So we're going to use the digital write. Now it's a digital write instruction. Check that the W here is a capital letter, the same as the digital read, that the R is the only one capital letter. So digital write, and we're going to set here digital write is going to be the pin that we need to write to that pin to turn the LED, as you remember, is pin number 2. So because pin number 2 is an output, so we're going to set 2, and we're going to take that pin to high. Close. And that's it. And let's check to be sure that everything looks good, that we end up the sentence the way it should be. Notice that this one does not require the semicolon as shown on this one. So the other thing is to remember, now you turn on the light, so you have to be sure that you take that variable, the variable LED status, and you put that variable equal 1, and then you close with the semicolon. And the next thing will be to close that bracket. Now, when you ask questions like, for example, if something, let's do this, but if not, let's do this other stuff. Then there's in Arduino, there's a instruction that will allow you to build that kind of a comparison and conditional. If this, will do this. If not, we'll do this other stuff. That comparison can be done with the instruction else, meaning if this, we'll do this. If not, meaning else, we'll do this other stuff. Notice that the else will open with bracket. Now, the decision here is simple. If it's 0, I want to turn the LED on with this instruction. But if it's 1, this will be ignored. Anything that is within these two brackets will be ignored, meaning that it will execute whatever is within the bracket of the else. We're going to add here some instruction. Basically, that means that somehow they are pushing the push button by the second time, and that would be to turn the LED off, meaning that this instruction that is here, I can copy that instruction, put it right there, add another one that says that the LED status now is 0. End of a story. The only thing that that is required in this small code is to ensure that I define the variable LED status, because it's a variable for this code. So that variable will be defined right here, and that variable needs to be defined Like for example, it's going to be a floating, it's going to be an integer. What type of variable? With a char. At this point, it's going to be an integer, very simple. It's only going to be holding number with no decimal places. If you want a number with decimal places, that would be a float. You will use the instruction float. In this case, it's going to be integer, meaning that's good enough, integer, and we define the word. It's going to be let underscore status and semicolon, and we're done. So let's get some space here. So you have variables up here, and then you have the void setup where we define the pin, whether pin will be output or inputs for the pin definitions. And basically, and here's the code. In the code, this bracket and this bracket, the last one, are for the void loop, all the void loop instruction. But it's interesting that here, while digital read equal high, if you haven't pressed the push button due to this design, the pin number 3 will be seen, will be at the high stage, the 5 volts. It's only when you press it that you go to low. Now, if you keep pressing the button, you keep it low, it will stay here until you release it. Otherwise, it will go through and the LED will be on, off, because it's missing this instruction here. It's interesting. If you don't put this, you will see something weird happening. All right. So I will say with that, I think that we are already done. There's nothing more to add to the code. As simple as that. Let's see that all semicolons were introduced. Yeah, semicolon, semicolon. This don't need the while instruction. They don't need the semicolon, and if they don't need it, else don't need it. But instruction to execute something, yes, they do, and that's why they have it. Now always check that the brackets are in pair. So like for example, this bracket and this bracket must be in pair. This bracket and the last one must be in pair. This and this, this and this, this and this, and the else, which is this one with this one. That will ensure that everything looks good. If there's a mistake, it will be the code when I start my software here. It will capture the problem. So everything went fine, no big deal. It's a very simple code. So the idea is if you press it here, it should turn on the light. And I'm clicking like I'm clicking the mouse. You don't click very quickly. So, you go through like 1001 and release it. Let's do it again. 1001. I got a mistake. Since I copy the code, that happened. So we stopped the simulation. The problem was here. Else low, because it would never shut off. But now, there we go. Oop. That will do. So now the code is correct. So what we need to do is start the simulation again. And press it, press it, press it, press it, and that will do. That's basically what this code will do. Is use the same push button based on the code. Now, if you press the button, I'm right now pressing the button. I haven't released it yet. Keep pressing it. When you release it, then it will do what you have to do. If you press it again, when you release it, it do what you need to do. See? Now, let's do a quick thing here. If I go to the code and do, like, for example, this instruction here, I will comment them. Since I'm commenting them, this is one way to do it. Adding forwards backslash like this will do the trick, commenting these 3 lines because they are together. Right now they are comments, not big deal. So they are like they are not there from the point of view of the code. So let's see how the code behave with that change. All right, so let's press it. I'm gonna keep it pressed now. Release it, press it. See, it's kind of weird. I'm pressing it, and it's not working the way it's supposed to. Somehow, I press it, but it doesn't seem like I'm getting the result that I want. And you can see the hesitation on the LED to work the properly. I click it, but you can see that it kind of faint a little bit, but it doesn't work. So it's kind of a weird behavior, very unpredictable of what is really happening. So let's stop the simulation and let's get the comment out. If I if I leave, so for example, comment here, the way it is, it will pull from, it will tell me that it's an error because there's a one bracket here that is missing. So if you start running the code, it will tell you, hey, listen, in your void loop, there's something missing. You see, error expected bracket at the end. All right, and it tells you all about it. So let's get out of here. Let's close this and let's fix the problem. So what is happening is this here. I like to get this organized. So now start again. And now press it once, press it back, press it one, press it back, press it one, press it back, press it one, press it back. Pretty much like you're clicking your mouse because we are in Tinkercad. The question is whether this code will properly behave on an Arduino with a typical switch where there's a problem perhaps with something called bouncing. You probably have to debounce a little bit the push button, and we'll see how that will behave. All right, so that's basically conclude this small presentation. The idea is that you have an idea how to program, in this case, a pull-up resistor, how to program a switch with Arduino with the instruction digital read, and again how to define whether the pin that you're using is an input or an output, and also the instruction while, what they can do for you. They're kind of cool, and the instruction if and the instruction else. All right, so that's basically it. As I always said, be safe, whatever be your final destination. Have fun. Bye.